Today is part 13 of the chapter Coordinate System and Straight Lines in Two-Dimensional Geometry. It is for preparation of JEE Main Advanced and for different state level joint entrance examination. First problem of today is problem number 54, and that problem is 1, 3, 5, 1 are opposite vertices of a rectangle. The other vertices lie on y is equal to 2x plus c. Then value of c is options 5, -4, 3, and -2. In this problem, a rectangle is given, of which these are this and that, they are two opposite vertices, and the other diagonal lies on that straight line. Then the value of c. The problem is very simple, of course. This is A, B, C, and D. A is given as 1, 3. Opposite vertex means C is equal to 5, 1. And this is a diagonal, not lying on this and that. And its equation is y is equal to 2x plus c. We have to find the value of c. Now, as it is a rectangle, its two diagonals meet at their midpoints. Suppose D E is the midpoint of the diagonals. From AC, from the diagonal AC, its midpoint is E is equal to 5 plus 1 by 2, 3 plus 1 by 2. That is, it is actually 3, 2. So 3, 2 is the point E, which is midpoint of AC. Obviously, E lies on BD diagonal also. BD, that means this diagonal. So it must satisfy it. Therefore, we must have C is, and y is equal to 2 is equal to 2 into x. X is your 3 plus C. So it gives us C is equal to 2 minus 6, that is -4. C is equal to -4. So option B is correct. Next, next problem is 55, problem number 55. And this problem is the equation of bisector of angle between 2x plus 2x plus 2y minus 3 is equal to 0, and 3x minus 3y plus 2 is equal to 0, in which origin lies. Option: 12x minus 5 is equal to 0, 2x minus 3y is equal to 6, x minus 16 is equal to 0, y is equal to 7. The problem is two straight lines are given, this and that. So it has two bisectors. Pick uh, mm, uh, one for acute angle and one for obtuse angle if they are not a right angle. Like that. Say this is that straight line, this is that straight line, this one. So its equation of bisectors. One is this for that angle, and other is for this angle. And this angle is, say, we have to find the bisector of the angle which contains origin. Means like that. Say, this is the axis system. Origin lies on that angle. So we have to find the equation of bisector of this angle, not that. We know that for two given straight lines, the angle of bisectors are number one, 2x plus 2y minus 3 by root over of 2 square plus 2 square, 8, is equal to plus minus 3x minus 3y plus 2 by root over 18. 3 square plus 3 square. Now, as I told you earlier, that the angle of bisector of the angle which contains origin, for that purpose we have to choose plus sign or minus sign in such a way that for that particular sign, constant term in the left hand side and constant term in the right hand side must be same. Now here there is no option, this constant is minus, negative. So we have to make it negative. For that purpose we have to choose this negative sign. Therefore the required equation of bisector is 2x plus 2y minus 3 by root over of 8 means 2 root 2 is equal to minus of 3x minus 3y plus 2 divided by 3 into root 2. So root 2 cancels. So required equation is 3 into, I write it here, 3 into, that 3 into this, 2x plus 2y minus 3 is equal to negative of that, negative into 2, that is plus 2 into 3x minus 3y plus 2. This plus that is equal to 0. That is 6x plus 6y minus 9 is plus 6x minus 6y plus 4 is equal to 0. Cancels. So that 12x minus 5 is equal to 0. 12x minus 5 is equal to 0. This is answer. So option A is correct. Next, now problem number 56. That problem is problem number 56. The distance of a point alpha comma beta from ax plus by plus c is equal to 0, comma, measured along a line which makes an angle theta with x-axis. Once again, the distance of a point alpha beta from this line measured along a line which makes an angle theta with x-axis is options. Modulus of a alpha plus b beta plus c by root over of a cos theta plus b sin theta modulus sin. Then a alpha plus b beta plus c divided by root over of 2 plus 2 tan theta modulus sin. A alpha plus b beta plus c divided by a cos theta plus b sin theta. Oh, sorry. It is a square, this is b square, and this is a cos theta plus b sin theta modulus sin. And fourth option is a alpha plus b beta plus c by root by a sin theta plus b cos theta modulus sin. Now question is, one point is given, one straight line is given. We have to find the distance of that point from this straight line. If only this thing is given in the problem, then we have to find the perpendicular distance of that point from this. But here it is given that distance to be measured along a line which makes an angle theta with x-axis. I mean like that. Say this is x-axis. Say a straight line is this ax plus by, that, and alpha beta is a point here. We have to find the distance of that point from this straight line measured along a line which makes an angle theta with x-axis. Suppose this angle is theta. So we have to find this distance. Now, equation of that line, it passes through the point alpha beta and makes an angle theta with x-axis. That is, gradient of the straight line is tan theta. So its equation is y minus beta is equal to tan theta into x minus alpha. Now, to make it parametric form, it is y minus beta by sine theta plus x minus alpha by, it is sine theta by cos theta. Cos theta would be there and sine theta is taken there. Cos theta is equal to r, say. It is now in symmetric form. Therefore, r would represent a distance from that point, alpha beta. And if I consider this point, this is our required distance. If I consider this point, then r is this. So coordinate of that point, say it is Q point. It is alpha coordinate of Q. It is equal to alpha plus r cos theta, comma, y coordinate beta plus r sin theta, where r is that distance. You see, this lies on that straight line, that is ax plus by plus c is equal to 0. It must satisfy that straight line, equation of straight line. So we must have a into x alpha plus r cos theta plus by, y is beta plus r sin theta plus c is equal to 0. So we get, taking r common, a cos theta plus b sin theta into r is equal to minus a alpha plus b beta plus b beta plus c. And because r is our required distance, so r is equal to, now it is equal to minus this by that, but it cannot be negative. So I give a modular sign, a alpha plus b beta plus c by a cos theta plus b sin theta. And this is answer. But let us check the options. First option is a alpha plus b beta plus c divided by a cos beta root over of, that is all right. Second one is all right. Third one is a alpha plus b beta plus c by not root over. Root over is not given here. And fourth option is okay. So our answer is a alpha plus b beta plus c by that, which is nothing but option C. Next. '57, problem number. And that problem is the line joining P x1 y1 and q x2 y2. Subtend a right angle at the point R 1 1. Then which one is correct? And no, not that. Then the value of x1 plus x2 plus y1 plus y2 is how much? First option is x1 y1 minus x1 y2 minus x2 y1. Second option x1 x2 plus y1 y2 plus 2. Third option is x1 plus y1 whole square plus x2 plus y2 whole square, and last option is x1 y2 minus x2 y1 whole square plus 2. This problem is also very simple. 2 points are given, say P x1 y1 and Q x2 y2, and one more point R is 1 1. Now the line segment PQ makes an angle, line segment makes an angle 90 degree at that point. Then the value of that, as because this is 90 degree, so this and that are perpendicular. Therefore, gradient of this and gradient of that, their product must be -1. That is, gradient of PR means y1 minus 1 by x1 minus 1, gradient of PR, and gradient of QR is y2 minus y1, only 1, by x2 minus 1, their product is equal to -1. That means y1 minus 1 into y2 minus 1, this is negative in that side, it will be positive here. x1 minus 1 into x2 minus 1 is equal to 0. That means from there x1 x2 minus x1 plus x2 plus 1. Now this plus y1 y2 minus y1 plus y2 plus 1 is equal to 0. We have to find the value of sum of x1 plus x2 y1 plus y2. So take this and that into other side, that is x1 plus x2 plus y1 plus y2 is equal to x1 x2, this one, plus y1 y2, this one, and 1 plus 1, that is 2. So our answer, this is equal to, that is this is equal to this plus 2. That is option B is correct. Next, Problem number 58. Equation of one side of an equilateral triangle is 4x plus, 4x minus 3y plus 9 is equal to 0. If its opposite vertex is at 3, 2, then length of each side of the triangle. Option 2 root 3, 3 root 2, 3 root 3, and 6. Given one equilateral triangle, one of whose vertex is this 3, 2, say A, and its opposite side is 4x minus 3y plus 9 is equal to 0. Equilateral triangle, this is one side, its opposite vertex is that. Then we have to find the length of each side of the triangle. Now each angle same, that is all 60 degree. Perpendicular is drawn from this to that. A, B, C, let it be D. As because it is equilateral triangle and perpendicular is AD from A on the opposite vertex, so if it is A, that must be A by 2. That must be A by 2. That is A. Now AD is the height of the triangle, and it is actually perpendicular distance of the point 3, 2 from that. So AD is equal to 4 into 3 minus 3 into 2 plus 9 divided by root over of 4 square plus 3 square is equal to 12 minus 6, so 15 by 5. This is 5, 3. So AD is 5. Now from this triangle ABD, it is a right angle triangle, perpendicular is drawn. So A square, it is hypotenuse, is equal to A by 2 whole square plus AD square. That is, it is A square by 4 plus AD square means 9. That is 3A square by 4, taking this into that side, is equal to 9. So A square is equal to, cancelling 3, A square is equal to 12. So A is equal to 2 into root 3. And A is the length of each side of the triangle. So A is, that is 2 root 3, that is option A is correct. Okay, let us stop today, and I request you to please subscribe my channel and share it to all of your friends so that they can be benefited from this video. Thank you.